this lesson we're going to solve a quadratic equation by completing the square. Using this method to solve an equation will be an extension of completing the square method earlier for a trinomial. So here's the algorithm solving a quadratic by completing the square. First we isolate the constant term on the right side of the equation. We complete the square on the left and add the same to the right. We factor the left, writing it as some binomial squared. Take the square root of both sides of the equation and finally isolate x to find its two values. So let's try x squared minus 5x plus 4. First thing we want to do is move the 4 to the other side of the equation. So if we minus 4 from both sides, we wind up with this. We want to complete the square. In order to complete the square, since we have a 1 here, we take half of 5. Half of 5 will be 5 halves. If we square it, so we're going to add 5 halves squared to this side, and we're going to add 5 halves squared to this side. So we have x squared minus 5x plus 25 fourths equals negative 4 plus 25 fourths. So if we factor, let's see, so we've isolated, we put the negative 4, we've isolated that, we've completed the square. Now we want to factor the left-hand side. X minus 5 halves, and we could write it twice, but it's going to be squared, equals, let's see, multiply this by 4 over 4, then we'll have the same denominator, so we'll have negative 16 plus 25 over 4. So now this becomes 9 fourths. Let's take the square root of both sides. So we have x minus 5 halves. The square root of 9 fourths is plus and minus 3 halves. So if we add 5 halves to both sides, we have x equals 5 halves plus or minus 3 halves. So this is actually two answers, and they're nice number answers, so let's figure them out. The first value of x will be 5 halves plus 3 halves. The second value for x will be 5 halves minus 3 halves. 5 plus 3 is 8, so we have 8 halves, or x equals 4 is our first value. If we subtract, we get 2 halves, or 1. So x equals 1, and x equals 4 will be our two values. Let's try again. This time we want to move 7 to the other side of the equation. So we have w squared minus 5w. It's going to be equal to negative 7. Since we have a 1w squared, half of 5 will be 5 halves. So we're going to add 5 halves squared to the left side and add 5 halves squared to the right side. So we have w squared minus 5w plus 25 fourths equals negative 7 plus 25 fourths. We can factor this as w minus 5 halves squared. Let's multiply by 4 over 4 to get the same denominator. So now we have negative 28 over 4 plus 25 over 4 gives us negative 3 over 4. Next we take the square root of each side. However, we're taking the square root of a negative number, which means we've run into a problem. So this is going to have not a real number answer. Anytime we attempt to take the square root of a negative number, we're running into a problem. Let's try one more. Suppose we had 3t squared minus 2t equals 3t squared minus 2 equals 2t. Let's bring this back over. Let's subtract 2t from both sides of the equation because we want all the terms to the left except for the constant term. So we move this over. Now let's add 2 to both sides. So we have 3t squared minus 2t equals 2. Notice we don't have a 1 in front of the t squared, so we need to factor out a 3. Factoring out a 3 gives us t squared minus 2/3 t. Now, since this is a 1, we want to find the value that we're going to square. We take half of negative 2/3, that will be negative 1/3, and we're going to square that. So we're going to add negative 1/3 squared to the side. So we have 3 times t squared minus 2/3 t plus 1/9. Now we need to do something to the right-hand side here. What did we really multiply or add? It looks like we added 1/9, but there's a 3 in front of it. 3 times 1/9 equals 1/3. So we actually have added 1/3 to the right-hand side. 2 plus 1/3, if we multiply by 3 over 3, gives us 6, or 6 plus 1 is 7/3. Now we factor. T minus 1/3 squared equals 7/3. Let's divide both sides of the equation by 3. So we have t minus 1/3 squared equals 7/9. Now we take the square root of both sides. Since this is positive, we're in good shape. So we have t minus 1/3 equals plus and minus the square root of 7/9. Now, 7/9 is the same as the square root of 7 over the square root of 9. So this is the square root of 7/3. So we have t minus 1/3 equals plus and minus the square root of 7 divided by 3. Let's add 1/3 to both sides of the equation. So we're left with t equals 1/3 plus and minus the square root of 7/3. We solve the quadratic equation by completing the square.